Well, welcome back, folks. Today we're going to do another shop talk. This will be shop talk number 5 in the series. We're now well into the fall of 2019. Weather's starting to change outside in my area. Just starting to see a little color change in the trees. And what I want to talk about today is running a new electrical circuit for some of my machines. If you watched I believe the last video I did on that little Black & Decker vintage bench grinder or pedestal grinder, I had alluded to the fact that I thought I was going to have to run a new electrical circuit to support my machines that are really in the middle of the floor plate of my shop. And I have done that, which is now the subject of this video. Now, this is not intended as a how-to or an instructional video for a couple of reasons. Number one, altogether it took me the better part of a day to run this electrical circuit. I have 6-7 hours or so at least into it, and even if I was to have shot and edited down the video, it'd still be likely a couple of hours. And number two, probably more importantly, I'm not qualified to teach electrical work. Now, I've done a lot of electrical in my life. In fact, I wired my entire pole barn over 20 years ago. I've done home remodeling, some home rewiring and remodeling projects, and I have had my electrical work inspected by electrical inspectors, and it has passed. I understand the fundamentals very well. However, I'm not qualified to teach, so I'm not going to show the details of wiring or pulling a new circuit. Rather, I'm going to take you through my thought process and the project as an overview only, so you can see what I did. We are still working on a little Yamaha Wild 1 on the side. I'm still chipping away at that, and I do have a couple of videos already in the can or shot for that, and they'll be released. Well, by the time you see this, they'll have already been released, and I continue to shoot new videos regarding the Yamaha. So that's not certainly complete by any stretch, so we'll be getting back to that here directly. But in the meantime, let me take you through the new electrical circuit I pulled for my machines as a subject of this video. There you can see the new drops for the new 20 amp electrical circuit that I just finished pulling into place. You can see the yellow drop boxes there hanging from the ceiling. And you can see, I think, the plugs there. You have to forgive the lighting a little bit in here. I want to talk you through a little bit the choices that I made. The plugs at the ceiling are locking plugs. In other words, they're twist locks. Everything in the circuit is 20 amp rated. 12 gauge wire with 20 amp circuit breaker and everything, including the locking plugs at the ceiling you see there. The outlets in those yellow handy boxes, those are metal by the way, are all 20 amp rated. The electrical cord hanging, that is flexible cord, that is 12 gauge stranded. And you can see I've got strain release on the boxes themselves, and then of course the plugs at the ceiling have built-in strain release as well. Those are about 5 feet or so off the ground, and I have a 10-foot ceiling in my shop, so I split the difference and went at about 5 feet down or 5 feet up, depending on your perspective. And the idea is that I can remove them by twisting and unlocking them from the ceiling. Those drops can be removed very easily. Just need a ladder to do it. And they're flexible, so if that one on the left gets in the way, I don't think it will, but if it was, I can either remove it or I can put a large loop in it and just get it up off the floor and out of the way. You can see I've got a couple of machines plugged into the rightmost box right there in the center of the view. I have my lathe, which is in the foreground, and the Black & Decker pedestal grinder that I reconditioned recently also plugged in. The handy boxes were painted yellow, obviously. I did that myself only for high visibility as well as the face plates. And I just wanted them to be very clearly evident to people if they were moving around the shop. The wiring was pulled internal in the attic, up inside there. I did end up going upstairs and pulling a fresh line of 20 amp or 12 gauge wire from the circuit breaker box, which I'll get in a little more detail on here in just a minute. But the gist of what I ended up doing is going upstairs and doing some rough measuring from the floor to determine where I wanted to place those boxes. In order to get the positioning correct, I measured off the corner right here of the drop-down stairways. That's a set of stairs that folds down from the attic to allow easy access up into the attic of the shop. So I ended up measuring off of this corner on the ground, on the floor, to get my approximate spacing. And what I did is I went 3 feet from this corner over this way, and I followed the center line of the trusses, so I had something to nail the boxes to. So I went 3 feet for the first box from this corner right here, and then I went 5 feet from this box over further for the second drop down cord. Then I went upstairs, and I do have lighting up there, by the way. I have, when the building was built, I put a couple of lights up there with their switch, just like you'd have in a room. And I went up and measured off from that same corner upstairs now. There's 22 inches of blown-in insulation, so of course I had to work around that. I had to put planking across the ceiling joists so that I didn't fall through the drywall, because the only thing up there is the structure. There is no planking down to create a floor. So I measured over upstairs that 3 feet, then another 5 feet, and took the box that I was intending to mount up there, pushed back the insulation, and drew an outline using the box for placement of the boxes. Then I took a multi-tool, my little 12-volt Milwaukee multi-tool, upstairs, and using the lines that I traced around the boxes, I cut the holes, the 2 holes for both boxes there from the top side. Then it was a matter of pulling the wiring over to the box. There's the electrical panel that supplies power to the building. I'm not going to open it up. I'm not going to show the insides of it at this point, but the circuit that I just added is the one on the far lower right here in the corner. Again, that is a 20 amp breaker. Most of the materials, or I should say many of the materials, I don't know if it was most, but many of the materials for this project I already had. I had that circuit breaker left over from some previous project. I don't remember what it was anymore. I had most of the fittings, the string release for the handy boxes. I had the cord, the drop cord from the ceiling. What I did end up buying was the 12 gauge wire. I bought a 50-foot coil of that. That's what I had to fish through the walls, and we'll get to that in a minute. I ended up buying the locking plugs that you saw a moment ago in the ceiling, the male and the female locking plugs. I had to buy those, and the 20 amp outlets that go in the handy boxes. I had to buy those. Everything else, the Romax staples, again, many of the fittings and bits and pieces I already had in my stash. In terms of actually pulling the wiring, that was the hardest part. It was a little bit of work involved, and part of the reason was, let me show you up here at the ceiling. You can see right there behind those flags an access panel. I had to figure out a way to fish the wire from the electrical box, the service box, vertically through the wall so I could get it up into the attic. And that is the way the original wiring to this building is done. In other words, the wiring enters or exits the box that goes to the lights and the outlets and the switches, goes vertical up into the attic, and then it's spidered out to the various locations in the walls. Well, I had to fish a wire. I wanted to fish a wire to follow the same pattern. So I had to cross through the sill plate or pass through the sill plate here at the top. There's a sill plate that runs, a double plate actually, it runs along here at the joint of the wall and the ceiling. And I had to be able to get the wire up through that sill plate and up into the attic. And what I ended up doing is just buying one of these inexpensive access panels that you can buy at almost any hardware store. I bought that at a big box store in my area, Menards. And I ended up cutting out the drywall. It was very easy to do. I just used the inside of the frame as a pattern. And I cut the drywall out so that I could have access to the wall behind it. And then I used construction adhesive to attach the frame. I painted it first to match the wall. It was stark white, and I painted it to match the walls, which are kind of an off-white. And then I just attached it with a construction adhesive, and it took only a few hours to really set. Then I had free access to the inside. Now there's fiberglass insulation in there, so I had to pull that or roll that fiberglass out, which was not difficult to do. And I was very fortunate because then the original wiring was exposed, and the original electricians who wired a shop, and I did have electricians do the wiring in this shop. I was working a lot of hours at the time, and I didn't really want to stretch out the project by doing the wiring myself. So I had it professionally wired. But nonetheless, they had bored an extra hole in that sill plate that they didn't use, a pass-through hole, which made it real easy for me, because then it was a matter of knocking out a hole in the top of this box here, and knock out the hole, commonly done, and then start to fish the wire from the ground up this way using a fish tape. I fished the wire up with the fish tape up through the insulation inside the wall till I hit that access space, and the wire came through with the fish tape. Then it was just a matter of pushing up through the hole in the top of the double sill plate and getting up into the attic. The problem in the attic is that there's only about 8 inches because of the way the ceiling and the building is framed. I only had about 8 inches of access, 8 to 10 inches of access back in that corner. And again, I had to crawl over there on my stomach on planks through 22 inches of fiberglass. Or no, it actually isn't fiberglass, it's blown in cellulose insulation. Very dusty though. It's not itchy, but you have to wear a mask, so that I could get access to that wire. And I couldn't quite reach it by hand. I just couldn't quite get in there, so I ended up making a hook out of an old broom handle that it broke off years ago. And I took a piece of copper wire, flexible copper wire, and made a loop, taped that copper wire to the handle of the broomstick. And then I had a loop in the end of the copper wire so that I could loop it over that exposed wiring coming up through the wall, the Romax, the 12 gauge Romax. And then I twisted it so that I had that Romax in a knot around that copper wire, and then I could pull it close enough to me that I could get a hold of it. My wife, then I recruited her, and she came out and she fed the wire up at the floor. She fed the wire up this way through the box while I was upstairs pulling it, so that I pulled most of that 50 feet of wire up into the attic and left here about 18 inches to 2 feet of wire hanging down so I could finish the wiring in the box itself. So now I had the wiring up into the attic in a big loose coil. It was a matter at that point of pulling the wiring across and stapling it to the framing in the attic to work my way over to where I had already cut those two outlet box holes. Once I got the wiring over here near where the stairs were, right up above the stairs, I put a junction box. Now the reason I put a junction box is that if I ever want to expand and add additional outlets in the future, I have an exposed junction box that I can tie into, and junction boxes should never be enclosed behind structure. They should always be exposed. And that one it's right at the top of the stairs, very easily accessible. So I terminated the line from the box, from the electrical service box, in that junction box right up above the top of these stairs, And then from there, it was a pretty simple matter of pulling the wiring from the junction box, tying it in there over to the two outlets over here. As you can see, it's not very far. And using the 12 gauge wire again. Then I had the wire just stubbed out into the hole, into the boxes, pulled what came down below, pulled the wire through, and then went ahead and mounted the plug-in outlets that I already had ready to go. And that was the basics of how I installed that wiring. I described it a lot quicker than what it actually went in person because, of course, I had to go up and down, up and down, up and down the steps. I did, again, most of it alone except for where my wife helped me pull the Romax through the wall up into the attic. And then she went on her way, and I spent the rest of the day finishing this up. So that's the project to add additional outlets. Those are about a third of the way over from the left wall into the middle of the room. And again, I can expand if I need to later. The reason I went with 20 amp service is because it's intended primarily to run machines. Like you can see here, I've got that Black & Decker. Oop, I bumped the camera there. You've got the Black & Decker pedestal grinder here. I have my lathe over here. And right in front, you can see my drill press right there with the hose, vacuum hose looped on it. I got to tidy this space all up. I've not done a lot with organizing this space recently, so I'm going to do some tidying up. But that was the intention, to avoid having to run extension cords from any of the walls to power these machines. I do have another lathe in pieces over in my pole barn, South Bend Heavy 10. I think it was built in around 1952, that I'm intending to bring into this shop, maybe even as soon as this winter, and start the restoration of that. Whether I'm going to put that in service here or not, I don't know at this point. I've already got that nice little lathe that I use, so we'll see about that at another time. But that was the project to pull that new circuit or service right there. And I thought I'd just take a few minutes to explain my thinking and how I went about it. Last thing I wanted to show you, just to assure you that the wiring was done properly. This is a circuit tester, and this uses a series of lights to tell you if your wiring is correct. There's the nomenclature right there. This is really intended to validate that your grounds, your neutrals, and your hot wires are all correct. So just to demonstrate how it works, you just plug this in. Now the way this is intended to work, if the wiring is correct, the very bottom one where it says correct right there, I don't know if you can see that or not in this lighting. Lighting's not great here. The red light should never be on. It would actually be like this. If the wiring is correct to code, this red light on the left should never be on, and the orange lights in the middle and on the right should light up. That tells you that you have your wiring correct. We'll just plug this in. And I think you can see that that is correct. The red did not come on, and the two orange lights are lit. So that validates that the circuit, the wiring for the circuit is correct all the way back to the box. So that's it for this Shop Talk number 5, just a bit of an overview of getting a new circuit pulled for my shop equipment. Any questions, drop me a note. Otherwise, as usual, thanks for watching.